Hi there. Today's lesson looks at algebra tiles and factoring polynomials. With arithmetic, it's the idea that we're studying mathematics to calculate a specific number, whereas in algebra, we're looking at relationships, so not necessarily just one answer to a question. Um, so what features can you tell that if you're dealing with algebra instead of arithmetic? Well, there's variables, and you need more than just one single variable. So you need maybe an x squared or x and y, something like this. It's kind of hard to put into words. The question is just made to make you think about it for a bit. Um, so is this arithmetic or algebra? 4 plus x equals 10. Well, how many variables can x be? Well, x in this one, I hope everybody can see, is 6. That's the only answer that satisfies that question. So I would say that that's arithmetic. How about this one? 4 plus a equals b. How many different values can a be for the above to be true? It can be just about anything. As far as we know, it can be anything. Because if b can be anything, then a can be anything. That's sort of the idea. So that's algebra. All right. So I'm asking algebra because we're using algebra tiles, and I have a bunch of text here that I hope you've read through. But just a quick explanation. When we're dealing with tiles, we start with the idea that we have a tile that's exactly one high and one wide, and it has an area of 1. Area equals width times height. 1 times 1 equals 1. The next kind of tile it's the same height, it's a height of 1, but the width is some variable. We don't know what that width is. We're just going to call it x. Okay? That's all we can say about it. But we also know, though, that the area is 1 times x, width times height, which is equal to x. And then finally, the third type of tile is a square. We don't know what its height is, and we don't know what its width, but we know that the width is equal to its height. And if we're careful when we draw it, if we take our same rectangle that was here and draw that rectangle here and rotate it and draw that rectangle here, we know that then the height of that square is x and the length of it is x. So area is x times x, or x squared. Okay, so those are the tiles. So now we're asked, consider these shapes. How many shapes with the exact area of 1 are there? There's one there and one there, so I'd say there's 2. How many shapes with area x are there? So 1, 2, 3, 4, 5. So I'd say there's 5 with x. And x squared, there's 1, 2. 2 with x squared. So if I wanted to write a trinomial that sort of adds all these things up together, well, I'd say, well, there's 2x squared, and there's 5x, and there's 2. Done. This polynomial explains what we see there. Now, the next one is consider this new set of tiles. So this is like a multiplication table. That's the idea. So we have a top row, and a first column. The top row is made up of 1x, 2x. So there's a 2x plus 1. So that binomial. And what areas make up the left column? Well, there's 1x there, and then there's 1, 2. So there's an x plus 2. So the question is, what do you get when you multiply these two binomials? When we multiply this binomial by this binomial, we get these areas, which we already did, and we know that that area is 2x squared plus 5x plus 2. So in other words, that's equal to 2x plus 1 times x plus 2. And what we're saying then is that these two binomials are factors of this trinomial. So if I said, hey, can you factor out 2x squared plus 5x plus 2? You could say, yeah, Mr. Smith, you can go 2x plus 1 times x plus 2. Working with an algebra tile is different than drawing them on a piece of paper. What I'm doing here is I'm showing positive values as being black, and if I had a negative value, like a -1, it would just be white. Textbooks use different colors. I think positive is yellow and red is negative. Here's some activities I think hopefully you've done in class by now. Let's write out a polynomial for these tiles. So there's 2x squared. 1, 2, 3. 3x. And there's 1, 2, 3, 4. And can that be factored? I would say most definitely not. X is not a common factor. There's no x in 4, so we can't factor out of 4. And in terms of whole numbers, we have 2, 3, and 4, and there's no common factor for those either. So I would say no. Next, you're asked to draw the algebra tiles for 9x squared plus 6x plus 3, and use your drawing to show the factors. So there's many different ways you can combine and draw these things, and it's just kind of trial and error when you're using when you're trying to draw them. But I'll show you how we can factor this out. We could have 1, 2, 3. I'm going to run out of room here. So there's 9x squared, and then I need 6x, so I'll go 1, 2, 3, 4, 5, 6, and then there's 3 small guys, 1, 2, 3. So there's algebra tiles for 9x squared plus 6x plus 3, and I'm also showing how it can be factored. Each one of these rows is the same. This is 3 rows of x cubed plus 2x plus 1. So that's the same thing as saying, oops, not cubed, what am I thinking? X squared. So last day we kind of went through how you'd factor this trinomial using the greatest common factor, and this is just showing how it's represented using algebra tiles. Next you were asked to draw algebra tiles for x minus 1 times x plus 4. I'll do it down here so we have more room. So here's x, so I'll do it how I was doing it before, x minus 1. So minus is negative, positive is black. So that's x minus 1 and x plus 4. So here's x plus 4. 1, 2, 3, 4. And I'm going to multiply these together. So I'm going to multiply those two things together. So x times an x is an x squared. So a big guy. X times 1 is x. X times 1 is x. And down it goes. Alright. Negative 1 times x is negative x, so that's not filled in. Negative 1 times 1 is negative 1. Just go down like this. Again, negative 1 times 1. Negative 1 times 1. So what do we get? We have 1 positive x squared. We have plus 4x here. 1, 2, 3, 4. We have a negative x there. And negative 4. 1, 2, 3, 4. So we can combine these two. That's x squared plus 3x minus 4. And that is equal to x minus 1 times x plus 4. So next lesson we'll learn how to do this numerically, or using the algebra symbols, but this is how you could factor out that trinomial using an algebra tile. Alright, next example here. We're asked to draw algebra tiles for this guy, x squared plus 6x plus 8. Factor it into two binomials. Alright, x squared plus 6x plus 8. So we got We know we have 1x squared. So therefore we know there has to be an x here and an x there. That's the only way to get 1x squared. And we're looking for plus 6x plus 8. So then we could go add 1 here. So x plus times 1 is 1. And we could add 1 here. X times 1 is 1. 1 times 1 is 1. Alright, so that gives us x squared plus 2x plus 1. So we're going to have to add some more because we're looking for more things than that. So we get x times 1 is 1, x. 1 times 1 is 1. So remember, we're looking for x squared plus 6x plus 8. I think that's what we're looking for. Yeah. Not there yet, but we're getting there, I think. Maybe we'll add another one here. X times 1 is x. 1 times 1 is 1. Still not there, hey? 4. We need 2 more. Why don't we try this? One times x is x. 1 times, so these are going to be 1s. We're getting pretty close. We have x squared. We have 1, 2, 3, 4, 5. We need 1 more x. This will give us 1 more x, I think. Yeah. There we go. That is x squared plus 6x plus 8. So that's trial and error. If you try drawing this, maybe you would try something else and it doesn't work out and you kind of have to go back and try different shapes. So how to factor it? Well, this is made up of 2 binomials. Up the top here we have x plus 2. And down the side here we have x plus 4. There, if we just factor this trinomial using algebra tiles. Alright, last example. X squared, this is supposed to be a squared, plus x minus 6. Again, we have 1x squared, so we know we think it's going to start off like this, I think, with 1 square. And that means we have an x times an x. And it's a negative sign, so I'm guessing we're going to need at least 1 negative. So I'm going to have that as a negative. So that's a negative x. And we'll probably have some positives too, so I'll go like this. That's a negative. So right now, the way it's drawn here, we have x squared, we have plus 1, negative 1, so those cancel out. So we have x squared minus 1. It's probably not enough. So let's try this. What if we go like this? X squared, those cancel out, plus x minus 2. Let's try another one. So that gives us x squared plus 2x minus 3. Now we have plus 2x, but we only want minus 1x, so we maybe try another minus. And I think that works out. We have an x squared plus 3x minus 2x minus 6. Yep, there we go. And that's equal to the 2 binomials. We have x squared minus 2. And on this side we have x plus 3. Alright, so that's it. That's factoring using polynomials, or algebra tiles. Thanks.